So this is our very first lesson in Unit 2 on logic and reasoning, and we're going to talk about inductive reasoning to begin with. Most of this unit is going to deal with deductive reasoning. So inductive reasoning is just a brief introduction to the idea that we can make a conclusion based on patterns and observations. Our essential question for today is, how do I use inductive reasoning to make conjectures? All right, inductive reasoning is the process of making a conclusion based on patterns and observation. All right, you could use inductive reasoning to notice that I wear a math t-shirt every Wednesday. And so you could make the conjecture that I am going to wear a math t-shirt next Wednesday. You might look around my classroom and notice that I have some Washington Capitals posters up. So you might use inductive reasoning to make the conjecture that I'm a Washington Capitals fan. If we make a conclusion based on definitions, postulates, theorems, mathematical or scientific fact, then we are using deductive reasoning. Most of mathematics is deductive reasoning. Most of real life is inductive reasoning. A concluding statement after you have used inductive reasoning is after you've made those observations, notice those patterns, that's called a conjecture. And if you can find an example that shows your conclusion or conjecture is false, it's called a counterexample. Very powerful. Whenever we're trying to prove something true or false, we're always trying to look for those counterexamples so that we can say the statement is false. So you have 4 vocabulary note cards to do for this particular lesson. How do I use inductive reasoning to write a conjecture? So let's look at some numeric patterns. Okay, let's see, how do we go from 38 to 31? I'm seeing -7, -7, -7. So my conjecture is going to be, I can subtract 7 from the previous number. To continue the pattern. So let's do that. 17 minus 7 is 10. 10 minus 7 is 3. 3 minus 7 is -4. -4 minus 7 is -11. And -11 minus 7 is -18. Let's look at the next one. Let's see, 2 to 5, that's +3, +6, +12. Okay, I'm not just going to be able to add or subtract. 3, 6, and 12. What if I do... 2 times 2 is 4, plus 1 is 5. So times, oops, somehow I got into highlighter here. Times 2 plus 1. 5 times 2 is 10. Plus 1 is 11. 11 times 2 is 22, plus 1 is 23. I think I have a conjecture. Multiply the previous number by 2, then add 1 to continue the pattern. Alrighty, so 23 times 2 is 46, plus 1 is 47. 47 times 2 is 94, plus 1 is 95. 95 times 2 is 190, plus 1 would be 191. At this point, I'm going to break out the calculator. 191 times 2 is 382, plus 1 is 383. 383 times 2 is 766, plus 1 is 767. Ooh, I recognize this next one. I recognize this next one because we started this year with a lesson on radicals and perfect squares. And 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. Okay. So I am squaring each consecutive natural number. Okay, so a couple vocabulary words in that sentence that you should know from Algebra 1. Consecutive, one right after another, like 5, 6, and 7, or -9, -8, -7. Okay. Natural numbers, or the counting numbers, the ones you learn as a baby. You start counting 1, 2, 3, 4. Okay, 0 would be a whole number, and we did not include 0 in this pattern. So a counterexample. We use counterexamples to prove conjectures false. Very, very powerful idea in mathematics. You can take a class in college called abstract algebra, where you spend the whole class trying to find counterexamples to prove things false. Determine whether the conjecture is true or false. If false, provide an example. The sum of any two consecutive integers is always odd. Okay, integers. 0 plus 1. Okay. 11 plus 12. 23 were odd. They said integers, so you better have negatives in here. -6 plus -7 is -13. I feel like we've done enough checking to say that this conjecture is true. The product of two numbers is always larger. Really watch out for words like always than either number. All right. 3 times 4 is 12. -3 times -4 is 12. What about -3 times +4? That's -12 is not larger than +4, so that's false. They didn't say we were limited to integers, they just said two numbers. So what about fractions, right? 3 times 1/3 is 1. That's definitely smaller. You only need one false example. As soon as you can find a false example, you can say false. One counterexample is all you need. Vertical angles are never complementary angles. Vertical angles, let me draw some vertical angles here. Okay, is there a way to make these complementary? Complementary has to add up to 90 degrees. Vertical angles have to be congruent. So 90 divided by 2, if I make each of these 45 degrees, this is a false statement. The product of two perfect squares is always a perfect square. Let's see. 4 times 9. 36 is a perfect square. 1 times 25. 25 is a perfect square. 9 times 16. Yeah, I'd say the product of two perfect squares is always a perfect square. So this is a true conjecture. Okay. Is this an example of inductive or deductive reasoning? So remember, inductive reasoning is patterns. Deductive reasoning is mathematical or scientific fact. Andy earned 100% on his first 2 math tests this quarter. That's pretty awesome. He concludes that he will always earn 100% on his math tests. That would be so nice if that was true, but this is inductive reasoning. Inductive, just because he got 100 the first 2 times doesn't mean that's going to happen again. Number 2, all birds have feathers. True. Since an eagle is a bird, an eagle has feathers. Well, that's some science there, so deductive. Every sheep I have ever seen is white. Therefore, all sheep are white. No, there are black sheep, gray sheep. This is inductive reasoning. Just because all you've seen is white doesn't mean that's all that exists. When the temperature reaches 0 degrees Celsius, water freezes. True. The temperature is 0 degrees Celsius, therefore water is freezing. This is scientific fact, so it's deductive reasoning. Okay, you need to write a 2 or 3 sentence summary on inductive reasoning, conjectures, and counterexamples. Be sure to include all 3 vocabulary words in your summary.